So I've been trying out Google Stadia this week.
Oh, boy.
Just a little bit.
You hipster, you.
Well, I decided to get the, what do they call it, like the Founders Pack or whatever.
Yeah.
My thinking is twofold. This is going to be somewhat good for Linux gaming, even if it's a little, because it actually requires developers target Vulkan and they have to target Linux
Right,
systems.
that's what's running on the back end.
And Google requires that. So I like that idea. But for me, it's sort of like outsourcing the bad, outsourcing the proprietary. With Stadia, I can have all free Intel drivers on my laptop, great power, low heat, all the stuff I want, but then I can open up a browser and I can play actual, real quality video games. That's the dream.
And when you're done with that, you can forget about it and you don't have this hardware laying around.
Or maybe I get home and all of a sudden like something changes in our plans and I find myself with a free evening. All I've got is systems that are incapable of really gaming.
Right. And that happens 3 times a year. So you're not really wanting to invest.
Well, then, I mean, you got to imagine too, right? As far as disk space goes, I mean, games these days are anywhere from, 20 to 100 plus gigs worth of storage. And if you don't play them all that often, you're just sitting there with a disk that's starting to fill up with games you don't play that often.
I had that problem. I had Steam installed and I was like, I haven't played for a while. I'm just going to delete all of this. And then you wanted to play with me and I didn't have any of it ready.
Steam Cache, bro. That's what you need to do.
Yeah, I know. That's going to happen at the RV, but that's a topic for self-hosted. What were your first impressions? You got to try it a little bit. You had the controller wired into my PC because that's the only way to do it.
I'm impressed. I mean, I'm definitely the casual gamer style.
Yeah. Mm-hmm.
More than enough for my needs. And if I had not known about Stadia and I just walked up and you gave me the controller, I was thinking I was playing any console.
Have you ever played Destiny 2 before?
Not 2. I played Destiny 1.
Because you walked in and cleaned that entire room out with a shotgun.
I mean, I may have played some video games in a past life.
I mean, like, you had some tactics too. Like, you went around the corner. I mean, yeah. So response-wise, it's pretty dead on.
Yeah.
What I see it as is you trade. So you could do some of these games on a cheaper GPU if you didn't want to invest every year, every couple of years in a big GPU.
Right.
But you'd have to turn down the textures, turn down the distance, turn down the reflections, the shadows, the lights. With Stadia, you can have mostly that stuff turned up pretty decently well, but you trade a little bit of fuzz when you got a lot of motion.
Right. It was a little bit of blur, but honestly, I mean, in the middle of the firefight, you don't notice any of that.
You're not paying attention because you're just really focused on the thing you're shooting at. So I probably am going to stick with it. My next big commitment, though, would be to move up from the free games to like the pay games, and they're like full price, Wes. And they just live on Stadia.
And of course, you're worried, how long is Stadia going to be around?
I mean, yeah, it is Google. Hello, friends, and welcome into episode 329 of your Unplugged program. My name is Chris.
My name is Wes.
Hello, Mr. Payne.
Hello.
Big show.
Huge show.
Hello, Cheesy. Hello, Alex.
Hey, girl.
Hey there, babes.
Hey there. And hello, virtual lug. Time appropriate greetings, Mumble Room.
Good morning.
Hello.
Hello.
Hello. We have about as many people in the quiet listening lobby as we do in the actual room. This new time's been interesting and well attended. I really appreciate it.
We're glad to see all of you.
So this week, we're talking about a problem I've been trying to solve. In the spirit of free and open source, I am scratching my own itch this week, and I am NAT busting with my VPNs. I have a situation where I'm behind carrier-grade NAT at home, and I want to create an overlaid network across all my machines that are on a Linode data center, on a DigitalOcean data center, in my RV, at the studio, when I'm traveling on my laptop. I want an overlay network that spans the entire internet that puts them all on one LAN.
Right. So you can just forget about it. It doesn't matter if you're here at the studio or you're down at Linux Academy headquarters. You can pop onto your home network, no problem.
There's a plethora of options to do this. We talk a lot about Wireguard. Wireguard's not necessarily the best solution for that. We'll tell you why, and we'll tell you what some of our favorite solutions are. And then we went and got interviews with the creators of them. So that's all coming up in today's episode. But first, we have some community news to get into. This one's nuts, Mr. Payne. Did you see this? Android, which has its very own weird, strange kernel legacy, its own strange sets of patches, may end up going mainline. I actually think this is one of those initiatives that's going to die on the vine about a year in, but...
Right. It seems like there's a lot of pressure and momentum against this.
Yes, well, people don't like proprietary crap in the kernel, but the current Android ecosystem is really kind of polluted with hundreds of different versions of Android, each running a different variant of their own Linux kernel. Each version is designed for a different phone and its different configurations. It's always the way it's been. And Google has been working to fix that problem by mainlining the Linux kernel, just going with a straight, upstream kernel one.
It's kind of the dream, right? I mean, we talk about all the great things about Linux and why upstream development is good, and of course we don't get any of that on Android. And that's because before it reaches you, the Linux kernel on your Android phone goes through 3 major steps. First, Google has to take the long-term support version of the kernel, whichever one it's going to use for that version of Android, and then add all those Android-specific changes. This is called the Android Common Kernel. Then this code goes to the company that creates the system on a chip that actually runs your phone, which is probably Qualcomm. And once the system on a chip maker finishes adding all that code to support the CPU and whatever other chips are on there, the kernel is then passed on to the actual device maker, such as Samsung or Motorola, and then they add code to support the rest of the phone, like the display and the camera.
Yeah, or maybe some new fancy feature that is their differentiator. Each of these steps takes a while to complete. That's how software and hardware development works. And it means at the end product, that kernel doesn't work with any other device. It also means that the kernel's very old, usually about 2 years old on an Android device when it ships. The Pixel 4, which shipped last month, has a kernel from November 2017.
Ouch. I don't even want to know what kernel my Pixel 3 is running.
I know. Now, Google did announce plans last year to fix this mess.
Yeah, that's right. They said, we know what it takes to run Android, but not necessarily on any given hardware. So our goal is to basically find all of that out, then upstream it, and try to be as close to mainline as possible. Kind of sounds like maybe we won't get fully mainline even in Google's vision. That might be difficult with Android's long history. It's a good goal, though.
Yeah, they did show it off on a prototype up on stage. I don't think it was perfect, though.
No, I don't think so. Does seem like some things were not working, like the battery percentage, which was stuck at 0.
That sounds like the Librem.
Ouch.
So what's Google's plan to make all this work? Well, they plan to take a page from their Project Treble playbook. Before Project Treble, the low-level code that interacted with the device and Android itself was just a big old stack of mess. What Project Treble did was it separated the two and made them modular, so Android updates could be shipped quicker, and the low-level code could remain unchanged between these updates. What Google wants to do is bring that same modularity to the kernel. Their plan, quote, involves stabilizing Linux's in-kernel ABI and having stable interfaces for the Linux kernel and hardware vendors to write to. Google wants to decouple the Linux kernel from its hardware support, end quote.
So this means that Google would ship a kernel and then hardware drivers would just be loaded as regular old kernel modules. Now, of course, this is just a proposal and there are still quite a few technical problems that have yet to be solved. I mean, that does sound like a big change, right? That's a different way to approach things, although I can see why some decoupling would be nice given these slower cycles outside the kernel development.
Yes, I don't actually think it's necessarily a bad idea. It's just such a radical change to serve one group's needs. It is a large group, but it is a radical change. I think the Android problem is not a unique one. There's probably thousands of hardware vendors at smaller scales in Google's shoes. They make a product that's an IoT device or something like that. It doesn't have to be Android. It could just be based on Linux, but it takes a long time for a group of people to build hardware and software. And so it's easy for a couple of years to go by, even if you're not a phone maker. Like phone makers probably have it down at this point. They probably have it about as efficient as they can because profitability is driving that. But Fred's IoT shop that's making router boards and stuff that get shipped in 100 different Chinese types of knockoffs, they don't have that kind of efficiency of scale. It's probably a much wider spread problem. So there could be some real logic in doing this.
I'll be curious to see what the upstream kernel community thinks of these proposals.
Yeah, it doesn't seem like it's got initially a very good reaction.
Right. And I mean, I wonder how much of it do you lose some of those advantages, right? The things that the kernel community is always talking about getting, proper upstream, traditional upstream support.
Right.
How much of that will actually apply here?
Yeah, they really want to see people just make it open source, make it GPL, and then it's just included.
We'll all maintain it together.
And that's a pretty deep philosophical outlook, which is why it's been really fascinating to watch Wireguard's slow march into mainstreaming. Wireguard is the VPN technology we traditionally talk about all the time on this show because we've been following it very closely. It's been held up by the adoption of its main crypto, which we thought may slide. We thought perhaps they were going to swap out the clever crypto that Wireguard uses for something already in the kernel. Well, this week, Linux.5.5 seems to support key elements of the Zinc crypto effort, which Wireguard depends on, which I thought wasn't going to happen.
I think what's happening here is, when Wireguard was sort of released, the crypto stuff kind of came fully formed, and the kernel community doesn't always love, oh, here's this giant chunk of code. Will you apply this patch, please? So I think what needed to happen was the kernel community and working with the Wireguard community and sort of working out which pieces made the most sense and in what order are we going to start making some of these changes. Mm-hmm. Thankfully, what's landing in Linux 5.5 is enough to unblock the dependencies in Wireguard. Now, with that said, Wireguard is not landing in 5.5, but should, emphasis on should, land in 5.6.
Yeah, I'll believe it when I see it at this point. It's just like been crazy because it's been every couple of releases we're like, well, the next one from this is going to have Wireguard.
The other good part here, too, is that we're just getting better crypto in the kernel, too, right?
Good point. Zinc looks like it's super good. But I think the thing that you'd mentioned is really the key underlying here. It's like just enough to unblock Wireguard. So we're not getting a complete implementation.
Right. And there'll probably be continued discussions on more code changes in the future.
I do love it, though. I think I could easily do an episode if we wanted on the open source projects that I'm loving this year because the list is different than it was last year. And
there's just so much good stuff.
Wireguard is definitely on that list. Game changer.
There's just some tools that they're great fundamental building blocks, and that means the things you can do with them are almost endless.
It's funny we're talking about 5.5. It's probably worth mentioning that 5.4 just came out.
Right.
So it's actually just shipped has been kernel 5.4. And one notable thing that we've mentioned in the past is it's coming with that lockdown feature as well as early extended FAT support. There's more details in Linux Headlines. If you're not listening to Linux Headlines, that's where we put that kind of stuff. linuxheadlines.show. I think that was the Monday episode because I think I did that one.
That's right.
And I think I covered it in Monday. So the details are in the Monday episode of Linux Headlines. But it's everything you need to know in Linux and the world of open source in less than 3 minutes.
3 minutes or less.
It's so great. It's so great. Well, guess what, Mr. Payne? It's time for a little housekeeping.
And it's about time.
First and foremost, learn.linuxacademy.com/Jupiter. We have a big Black Friday sale going on right now. It takes $150 off the price of the membership.
That is huge.
Huge.
Wow.
And the way the Linux Academy discounts work, if you keep your subscription active, that price remains what you pay forever.
It sounds crazy because
we're always adding new stuff.
That's what we do.
Like, new content is in the pipeline constantly. And so the value is nuts. The key differentiator about what we do at Linux Academy is the hands-on labs. You go in the real environment and you experience this stuff. Everything's there you need to do like all of the paperwork stuff to take the exams and get your certifications. Absolutely. Absolutely have that. But when you have to go work in the real world, you want that hands-on experience. And our training architects have built these hands-on labs to help you get there. So go to learn.linuxacademy.com/Jupiter.
And of course, that'll be linked in the show notes.
Black Friday sale. It's only going to like the 6th.
Yeah, December 6th is when our sale ends.
Yeah, so jump on that because it locks it in. And there's so much good stuff in the works. Really big things. Learn.linuxacademy.com/Jupiter. Last week, we talked about the System 76 Superfan event. Well, Cheesy, you got updates on that and some Pinebook updates too.
Yeah, absolutely. So, we didn't get a lot of time to cover the Superfan event because we were pretty packed that show, but I've done a write-up there, and if you go to linuxunplugged.com and hit the blog tab, you can check out that write-up. A lot of cool pictures and just really a great synopsis of the event itself. It was wonderful. It's really interesting to be around Linux nerds that are actually producing hardware. It was just an experience that you'll have to go read for yourself. And I've also updated the Jupiter.gallery page with some photos from that event as well, and also included a Pinebook Pro review. So if you caught last week's show and you want a little bit more information, I suggest you hit the linuxunplugged.com blog and check out those posts as well.
I love it, man. What's neat about that gallery, first of all, I got to say these posts, you did a great job. So thank you for writing these up. But what I love about that gallery is you get to see some insides of the System 76 warehouse. You got some in this post too. Like, I love this picture of Carl. He should make that his Twitter profile picture.
Absolutely.
That's amazing.
That's really good. So you can find those at linuxunplugged.com/articles. This is something we try to do. You know, we talk about this stuff in the show, but we've recently, within like the last 9 months or so, started doing these write-ups and posting these pictures. So that way you actually have a little more too than what we're just saying here. You can go see what we're talking about, get a better sense of the vibe. And Cheesy has been doing a great job of updating the Jupiter gallery, jupiter.gallery. So go check that stuff out. Al, also, did you mention your ThinkPads with Popey episode?
Oh, dude, that was such a fun episode with Popey.
Anybody that's looking at like a used ThinkPad and wants to kind of know what might be the right one for them, but also what you can replace and fix after you bought the ThinkPad, that stuff blew my mind. I had no idea. So that was a great episode. That's over at Extras. And while I'm talking about Extras, I'll mention it because we're on a roll right now. Extras is on YouTube. All of them are now posted on YouTube. If you're a YouTube connoisseur, I'll have a link to the channel. We don't have any subscribers yet because we just turned this thing on, so we don't have like a name.
Go subscribe and you'll get little notifications when we got new stuff in there.
How many subs do we got to get to name it?
100 maybe?
Maybe it's 1,000.
Might be 1,000. Either way, we need your help.
Yeah, so you'll find the link at linuxunplugged.com/329. Go subscribe so that way we can give it a name. And we'll be posting all of the extras on YouTube as well as extras.show. It's all over there, including that Popey on ThinkPads episode. That extra stuff is so good. I should also mention, Brent isn't here today, but he did message me earlier and said a new Brunch with Brent is out with Jacob, and it's fantastic. And he talks about how TechSnap specifically got him into the industry.
Oh, yeah. It sounds like I've not had a chance to listen.
Yeah.
Because it just came out this morning.
Jacob's a good guy, though. I've had breakfast with Jacob. It's good. It's good. Brunch with Brenton. Breakfast with Jacob. All right, that's the housekeeping. Now let's get into these NAT-busting VPNs. So we're not talking about Wireguard this week. This week, we want to create a mesh network of sense, or an overlay network. And the granddaddy from the 90s in this space is Tinc. So how does Tinc differentiate from Wireguard, Wes?
Tinc is quite different from Wireguard. Wireguard is very simple, which is great, right? That's one of the things we love about Wireguard. But when you're making a Wireguard connection, you're really just making, one point-to-point link. You've got where the machine you're connecting to and the machine you're connecting from. Tinc can do a whole lot more. Not only does it also have support for things like Layer 2, but it's a mesh network. So it has a concept of understanding all the different nodes you've got on the network. It manages that. And
the best routes to those nodes?
And it can figure out the best routes to traverse that network. So as long as two nodes that you've got on your Tinc network can talk through somehow, they will find a way.
So you could set up a public relay on a VPS,
Exactly.
and you could have, like my systems, which are behind a massive carrier-grade NAT. It is punishingly awful, but Tinc can accommodate that.
Yes, very much so. It'll
as
try
long
to
as
figure out
one node's
whatever
public? Is that-
whatever. Yeah, you just need enough information, and usually having some sort of public node not behind NAT, that will make things a lot easier. But it's got a lot of sophisticated NAT busting integrated right inside of it.
So we sat down with one of the original creators of Tinc, and we asked how did he get the idea for Tinc to begin with?
It started out when I found this new feature in one of the very early Linux kernels. So it was called EtherTap. It was the predecessor to what's now called Tun. And I wrote a little program to experiment with it. And then naturally I created some kind of tool to create a network connection between two computers and tunnel the packets back and forth. And that was already a working kind of VPN. Except it didn't do encryption, or it was very hard to actually set it up. You had to do a lot of things manually. And then a friend, Ivo Timmermans, he joined in, and he actually took this a step further, and he made a proper daemon out of it, introduced encryption. And then, also with some other people who joined in. But I think Ivo and me were the people who coded most in the beginning.
So how long ago was this, roughly?
So we started in 1997.
Wow, that was a whole other internet.
That is literally another internet ago.
Yes.
What's that like? What's that like, a project like this? I mean, there must have been moments of security panic. There must have been moments of trying to decide if it's worth modernizing as the kernel changes. I mean, there must have been all kinds of things to keep up with over that time period.
Yes. Well, you mentioned a few things that indeed happened. It started out as kind of a hobby project. So we were all students back then. And we actually wanted to have our own private network that so we could exchange files easily without having to, without being that visible to the rest of the network.
Of course.
And one thing was that, of course, we were not the first one to invent a tool like this. There were already commercial solutions, or I think we had Phaeton and Sipe in the Linux world that did something similar.
Was the beauty, though, that it really sort of created a truly flat mesh network? I mean, you could have friends all over the world, essentially, that are in one flat network.
Exactly. So, for example, Evo was not in the same city as we were. So this was a good way to make sure that we could access his computer and run things like IRC and FTP.
I like the idea you can use it for development resources of the project you're developing.
Yes.
Absolutely. Yeah. So I noticed that the project for a while has been nearing 1.1. It's not so it doesn't seem like the project's moving at 100 miles per hour, but just as of a couple of months ago, there was an update on the news list. So things are still continuing. So development continues. How would you describe the pace and future velocity of that?
Yeah, it's very slow, sadly. So 1.0 is quite stable, and I'm not planning to add any features to that. There's still users who sometimes find bugs or say, well, okay, if with this little change, it will be more useful for us. So then we try to implement that. And then, of course, there's 1.1, which is a big improvement over 1.0. I just need to find time to finally finish this.
Of course, that's always hard.
I thought several years ago that I would have the time to do this, but unfortunately, I'm not a student anymore. So I have a proper job and a life.
Right.
So.
Real work comes first, yeah.
Yes.
What sort of features might we be looking forward to when you do find that time?
I think already a lot of the features that I want to have in Tinc 1.1 are there, but there are some rough edges that I want to have smoothed out. One of them is, for example, key management. So already it's a big improvement over 1.0. It's much easier to create keys, exchange keys with others, also in a secure way.
Oh, that's great.
But one of the issues is still, I would say, handling key renewal. If, for example, your public key is compromised somehow, you want to update it and you want to make sure that all the other nodes in the network get that new key in a safe way.
Yeah, absolutely.
Also, if you don't trust someone anymore, at the moment, it's kind of a manual process to block this person or this node on all the other nodes. And it would also be great if that would be done in a much more automated way. But that requires some changes. So there is no infrastructure at the moment to spread that information throughout the network.
Right. That sounds like a lot of coordinating to coordinate.
Yes.
I'm curious what you might see as on the larger side of a Tinc network. About how many nodes have you seen out there?
So myself, I've seen networks of over 500 nodes. One of the biggest ones that is kind of public is the Chaos VPN network. So it's the kind of the European hacker spaces. They are united using this network. And there's actually a counterpart in the US, DN42. Where they use various technologies, including also Tinc. That's quite a large network. But I've heard from other people that they have similar sized networks. And there are also businesses, companies that use Tinc internally to connect offices together. And it's very hard to get information of exactly how many nodes they have and so on.
Yeah, I would imagine people are in part doing this for security, so they're not keen to share all their details.
No.
But I'm just always fascinated because I can see it working well for myself with a dozen nodes. But I was just curious, since I probably won't ever take it that far. I was just kind of interested to see how far it could go. So it sounds like 1.1 is still out in the works, but not necessarily a timetable. But as far as features go, really everything that's in the release now is pretty solid. It's there. It's fairly feature complete.
Yeah.
As we noted, Tinc's been around for a while. I'm curious if there's any features about Tinc, things you love that stand out as reasons to use Tinc. I mean, there are more competitors these days, but Tinc is still great software.
Yeah.
Well, one thing that I think makes Tinc stand out is it doesn't impose any kind of restrictions on the network topology you use. If you try to configure Tinc, you will notice that there's nothing in a configuration file that basically says use this IP address or this subnet. Basically, it says, well, you can create a script yourself, which Tinc will call for you. But in the script, you have to configure actually the virtual network interface that's created by Tinc.
Right. So you have all the control. You can modify that, make it configure whatever you need.
Yeah.
That is great.
Right. And it also strikes me as similar, Tinc supports layer 2, which a lot of the newer VPN solutions just sort of skip. But that can make for very flexible implementations.
Yes.
Yeah. It seems particularly attractive for someone like myself who's behind a NAT, and it's a particularly challenging NAT. I've got a VPS. I can throw Tinc on that as well and kind of Tinc can sort of navigate that for me and solve that problem. And that's what makes it really special for me. Well, Hus, thank you so much for joining us and just kind of giving us some background details on it. I find this stuff fascinating, and your project is one of those that's been around for such a long time. It's sort of an unsung hero to a lot of people where they find and it solves that perfect problem, but it's not a project that gets a ton of attention either. Really appreciate you taking a moment so we could shine a little light on it.
Well, thank you for having me.
So let's kind of define more specifically how we're using the term overlay network and what we're using it for. I'll give you an example, a day-to-day example. Myself, Drew, and Wes, we all have home studios, and we'll sometimes need to connect into resources here for production purposes, or sometimes Chris forgets to export an episode of Linux Action News and somebody needs to remote in. And
never happens.
Never happens. And we all need to connect back to JP1. I would like to connect to my home network as well, regardless of where I'm at from my laptop, and be able to connect to the JP1 infrastructure. And so I needed a solution that could kind of create an overlay network for all of this, one LAN.
Right. There's sort of there's a magical feeling when you have a flat network because everything's accessible. It just feels right next to you, right at your fingertips.
Yeah. Yeah. Things that like do auto discovery, like old video games, like StarCraft. You can all see each other. It's a really unique experience because you can be on a Raspberry Pi on a MiFi connection in an RV and be pinging a box in the studio like it's just a local machine.
Right. And you can simplify some things and work across regions. Maybe you've got different providers or different data centers. You can make things flat that way too. Unfortunately, I've used Tinc and we started evaluating Tinc for our use case here. And we ran into some problems because really we've got a few different security domains. I don't need access to your home network. No. And really, there's some parts of the studio that we only need access to a few machines here at the studio.
Right.
Tinc doesn't really have any filtering capabilities. There's nothing built in to help you manage multiple different sets of users. And when you want to add a new host, well, if I want to talk to a new machine that you've added to the studio, you got to go give me a new file that's got all the information about that. Mm-hmm. And that works okay for a few machines, but if Drew's adding a new machine that he wants to share with us, it gets tedious fast.
Wes and I were pretty excited when we saw Slack announce Nebula, an open source global overlay network, and we invited Ryan on to tell us about it. Ryan, this seems like something that's it's pretty notable that it's a pretty big open source project from Slack, but B, it seems like it's pretty well developed. Like it's a complete ready to go solution.
Yeah, that's right. It's funny to have Nebula out in the wild and people seeing it for the first time because it's actually old news inside of Slack at this point. It's 3 years old.
Oh, wow.
Oh, okay. Yeah. So you've been using it in production for a while then?
It's been in production for about 2 of those years.
All right. So an overlay network, it seems like you could have accomplished this possibly using IPsec or maybe even Wireguard with some really sophisticated routing. I'm guessing that was tried and done and didn't work. Where did that kind of fall down for you guys?
So our original network, and are you going to provide a link to the blog post in the show notes possibly?
Absolutely. Your Medium post and also the official announcement too you bet. Yeah,
great.
We've been reading it voraciously.
Great. Yeah, so we actually did IPsec originally, and we ran into so at first it was fine, right? As you expand out, you have one region in a cloud provider, and everything's fine. And then you expand to another region, and IPsec was kind of the obvious choice for connecting multiple regions. It was the most supported way. There are now in the past year or so, they've added support for connecting remote regions that don't require VPN. But we can get into that in a minute. So we used IPsec out of the gate, and it actually worked fine in the beginning, but as we scaled up, the complexity grew, and I jokingly called our IPsec setup our RAID 0 network configuration because the problem was you had to do these kind of strange routing tricks because no one box could handle the traffic, and because of that, if you lost any of the boxes on one side, even one of them, you lost routing to an unknown number of nodes. And so it wasn't really viable to keep running that remote region that way. So we would have to offline an entire region, hence RAID 0 network configuration.
No kidding.
That was one of the major challenges. And so we were already many thousands of servers at that point, and there were also folks that dissuaded us from using IPsec at scales that we were, planning to hit. And I can't speak to whether they were correct or not, but that was a caution that even some folks that work with IPsec regularly, they said in transport mode, which is sort of the node to node version of IPsec, they said you might start to see performance issues when you're above 1,000 nodes. And again, this is secondhand, so I'm not saying that we saw that. I'm just saying that was kind of a warning that I was given. And so when we thought about the problem also, we looked at, kind of traditional VPNs. And one of the things that we didn't care for was having to tell every node about every other node ahead of time.
Right. That's a lot of overhead, and you have to manage it somewhere, configuration management, or it's got to be somewhere.
Yeah. And it's not just that, but think about when you get to many thousands of nodes, say you're running a dynamic environment where, hosts come up and auto scale and that kind of thing. A host comes up and you have to ensure with some measure of certainty that every other host it might talk to has the proper key before it starts talking to that host, right? And that becomes a complex to manage problem when you're talking thousands of hosts. And so we went a different way with Nebula, and we did certificate-based authentication between nodes.
And another part that I noted, certificate authentication is notable, but the other thing that I noted about this that seems to stand out is groups play a large role in sort of the access control of this.
That was one of the events that was really the moment we decided to write Nebula. And so the primary authors are myself and Nate Brown, who also works at Slack and has worked there for 4.5 years. By the way, a bit of history. I've worked there 5 years and was the first security employee. Nate has worked there 4.5 years and was the second security employee. So
that is fantastic.
Yeah. So we've been there quite a while, and we've actually done some really fun work outside of this. But so we were actually just chatting, and we were actually, I know you mentioned Tinc before the show. We were talking about that briefly. I really like Tinc. Tinc's this great project from the 90s, and I think the guy's name is Guus that's been working on it. And it's got some really, really cool routing tricks and sort of gets around NAT and that kind of thing. And so we actually very seriously looked at what it would take to use Tinc, or maybe contribute back to Tinc and go that route. But what really led us to writing Nebula was this idea that we wanted to encapsulate security groups, as you mentioned.
This, at first I struggled to quite understand this, but when I started looking at the example configuration files, and I saw an example in there where it was broken down by servers, laptops, it started to click a little bit more that you could start to manage a much larger set of machines by grouping them up.
Yeah, maybe you could clue us in on how you guys are using groups?
Yeah, so the kind of contrived example, I mean, we actually tie groups to chef roles. So if you're familiar with, so with config management, because the chef role really describes what a host or what a container's job is, then that kind of makes a natural grouping. And we also add in some special stuff like which region it's in, which availability zone it's in, that kind of thing, just so that we can do even more fine-grained. And we opportunistically add groups we might use, and even if we don't actually use them for filtering rules, but we add as much kind of metadata as we can about hosts. And so, the contrived example I give is, if you're a database server and say, in a very simple setup, you just allow web servers to talk to that database, then the only rule on your database servers is, assume MySQL. The only rule on the database servers would be, I allow TCP 3306 from anything that's in the group web servers. And that's powerful because you no longer have to care about IP addresses or host names or anything. And this isn't new, right? This is something that, cloud security groups have existed for a long time. The difference is Nebula security groups are, they're cross-platform, which is pretty cool, but they're also cross-provider and cross-region.
Right. That is a big deal.
So this, we're talking about as an overlay network, and you can really use this to stitch everything together. Is this a lot of traffic then going through Nebula?
Yeah, I don't have the numbers in front of me, but it's many billions of packets per second. It's really neat to see. Yeah, it's in heavy use.
I can only imagine what it must have been like to evangelize that inside a company and then roll it out and then have to work out the kinks. That must have been quite an experience.
Yeah, there were some fun times, especially in the early days. One of the really great things about this project in general, and kind of following on some of the other projects I've worked on and Nate's worked on, is this is something we also just wanted for ourselves, right? So there's that selfish aspect, which is we want this to be great for Slack. We also want to use this for our home networks and everything else. Like we really wrote it for ourselves and for Slack at the same time.
So tell me the thoughts behind going open source.
Yeah, there are a lot of good reasons to do it. I think the main one is, everyone says they give back to the community, and I very much agree. Like, every company is built on so much open source software that if you've done something that can save someone else time and it doesn't, degrade your security posture, there's not a business reason, I think it's really nice to open source software in general.
An open source by default sort of thing.
Yeah, and I think we've been pretty good about that. Anytime we've had something that's sort of generally useful, we've kind of put it up there. But the other reason is getting more eyes on it and just having more people use it. So one of the things that I lobbied for internally was to add Nebula to our official Slack bug bounty program. And so that, that means that when we put this out there, if people find security related flaws in Nebula, we'll actually pay them for those through the Slack bug bounty process.
That is great.
Yeah, that was a big one for me because, again, this is a pretty key part of our infrastructure. And on top of it, some amount of trust from a community when people are using it. And so, we wanted to make sure that we weren't just throwing this over the wall and then saying good luck.
I love that. I think we're seriously considering using it for remote studio productions to connect back to the main studio. And looking through the configuration, there's a couple of things that I really love. Like the beacon service, or whatever you want to call it, is named Lighthouse. So we can put that on an external system. That's great. That's a great name. The server, I don't know what you call it, but the function to make sure that the NAT mapping remains is called Punchy. It keeps punching a hole.
That's so cute.
My friend and colleague Nate hates the name Punchy, so I'm going to make sure and play this section, but I called it that. It made me
smile.
Yeah, and there's some other stuff that over time we really learned. I'm not speaking ill of GoGo, but one of the best debugging steps we had was whenever I would be on a flight using this. The latency over that really taught us a lot about some of the handshake issues we might run into in extreme cases. So that was pretty neat. The core of Nebula has existed and been in production for 2 years, but we've added features, sort of as we worked on it. And you mentioned Punchy. One of the features that we added not long ago, probably 6 or 7 months ago, I don't have it in front of me, was something called Punch Back. And I don't know if you saw that in the config as well.
I think I did, yeah.
Yeah, so sometimes you're behind a really difficult NAT, and like a symmetric NAT, I won't go into the details of why, but a symmetric NAT can be extremely difficult.
Oh, I live that life right now, actually, on one of my systems.
Are you on mobile?
Yes.
Yeah. So you would really enjoy Punch Back. And I actually did that because I use a hotspot quite a bit of the time as well. I really enjoy road trips, and so I have like an AT&T hotspot.
Kindred spirits.
Oh, you're speaking my language.
And so what Punchback does is when a host wants to connect to another host, it asks the Lighthouse how to reach it. The Lighthouse gives back a UDP or an IP address and a UDP port to try. And when I query the Lighthouse from a node, it also signals the node I'm about to connect to punch outbound to me. Right. So as I query the Lighthouse and ask about a node, the Lighthouse is signaling that node that I'm about to try and send a packet to it, and it should punch out. And by the way, a really important thing here is the Lighthouses actually don't transit any of these packets. They are purely for querying and finding nodes. The handshake never goes through a Lighthouse. So and so the Lighthouse signals that node to punch out, and then we start sending packets, and we try all the different IPs that we know about or that we've learned about. And the thing that Punchback does is it says, okay, the Lighthouse signaled me that somebody's trying to reach me. I'm going to give it 5 seconds. And if they don't reach me, I'm going to try and reach them as though I had initiated the connection. And that, as long as there aren't 2 boxes behind really terrible symmetric NATs, that works almost every time.
Oh my gosh. Well, I think that just sealed the deal right there.
I mean, it's clear that you've had to fight through some of these things and worked out a lot of those kinks.
Yeah.
Oh man, that's so fantastic. Ryan, this is one of those moments, you always hear it's almost cliche. Like the thing about open source and free software is everybody's scratching their own itch. It sounds like in this particular case, you had exactly the same itch. And I just am so thrilled. I think it's great. I will link to the announcement, and we're going to play with it. We're absolutely going to try it out.
Yeah, is there anything we need to know? I mean, we've talked about a lot of good things here, but is there anything as potential adopters we should be aware of?
Depending on the platform you run, there's some stuff that hasn't been merged yet that's going to make that easier, especially if you use any Macs or Windows devices. And so one of the difficulties in Windows that when I was sort of developing some of this with a friend, by the way, there's a gentleman that we work with named Wade who did every port. So we wrote this for Linux, and he ported it. And Go makes porting just so nice, but he ported it to Windows and Mac, and even in one single hack day, Wade is the person that got it running on iOS. So,
wow.
Yeah, it was really impressive stuff. And
that's fantastic.
But one of the difficulties with Windows, I haven't run Windows as a primary OS in many years, so I'm kind of out of date on it. But one of the issues was installing services and how services need to behave is kind of, it's very foreign if you're used to Unix style, services. And so there's a really nice Go library out there that can make a binary service aware. And so I integrated that into Nebula and made a version of Nebula that's a self-installing service. And so in that case, you can actually copy nebula.exe and one config file to a Windows host, and then you can run nebula-service install, and it actually does the whole bit and installs it as a Windows service. And that library is actually cross-platform. It's really neat. So it even does that on Linux or OS X, whatever you're using. We have a bit of a pedant's argument about doing that on Linux. So I don't think that'll be the default build on Linux, because just use systemd or upstart is kind of the right way to go.
Right.
But for the other OSs, OS X or Windows, I think that's going to be the default behavior very soon. And there's a branch that already works.
That's one thing I mean, you can't miss about Nebula is
Yes.
that simplicity. It just seems ready to integrate into all kinds of other systems, however you might do it.
Yeah, we were brainstorming a couple of ideas already. Ryan, I hope you'll keep us in mind in the future if there's any developments you want to share with the community. We'd love to pass it along. I think you can count us officially as fans of the project.
Well, that's great to hear. I know people probably say this and it sounds cliche, but I was really surprised how many people were interested in this. Because before we put it out there, you know, we knew we were super into this, but you always think your thing is really neat and you hope other people do. But the response has been really great, and we're really happy about that, and we want to keep that going. So we're going to do some things to make it even easier to stand up Nebula, especially for folks that maybe don't want to stand up a lighthouse and do all of that just to test it out. So we're going to make that a bit easier going forward, and I can't wait to see what use cases people come up with.
Very good. Well, thank you for joining us.
Thank you.
Something we didn't touch on, but Nebula has also undergone a paid security vulnerability assessment along with numerous internal Slack reviews as well. So it's looking like it's in pretty good shape.
Yeah, they're certainly using it.
And we did give it a go. In fact, we have been really having quite a bit of fun playing around with Nebula. It's been one of those projects that just is like, you feel like it's cutting edge, but it's doing something that solves such a cool problem. It's great.
And it's simple. It's easy to get started with. I mean, it's Go. So you just go download the 2 binaries that you need. And the configuration files are easy. It's just YAML. And because of the way it works, you don't need a whole bunch of configuration files. You basically just need, you know, the key pair for your machine. You need the CA certificate and then the config file for the daemon, and you're done.
Yeah, it's a lot. It's a lot of kind of like conceptual stuff. You have to shift your head a little bit because it's all key-based, so you got to get used to that. But that's not a big deal. It's not necessarily like a service. It's not going to be a package you install. It's a tarball you download and extract and you run it. But if you're okay with and you're comfortable with those kinds of things, with very minimal effort, you can create an overlay network that is secured, and it's like browsing a local LAN for fun. Like we went on 2 different MiFis. Wes did it from his place. I did it from the RV. We have systems at the studio,
and they can just all immediately talk to each other. And it'll be smart about things, so it'll figure it out. You know, if I'm at my house, I can talk to one of the studio machines. But if I come into the studio, they figure out that that traffic just stays on the local LAN.
So we even got it going on my Raspberry Pis to an extent. My Raspberry Pi 4s, I think, did we figure out they were in 64-bit mode? I can't remember now. But there's a 32-bit and a 64-bit version that'll run on the Raspberry Pi. And we got it working really solid for a bit on one of my Raspberry Pis. But when we set it up on a second Raspberry Pi, we ran into some strange issues where it really kind of came into our limits of the ability to troubleshoot. And because this is new, there isn't a huge community around it to solve it.
Yeah, and there are some downsides. It is very simple. It just means that there's, it only operates in the one mode. And right now, the NAT punching doesn't seem quite to be working. There are some extenuating circumstances because, as you said, you have 2 layers of NAT, which makes just about everything difficult.
I have this fantastic best ISP I've ever had in my life, local ISP. They're like one of the last in Washington, little small outfit.
Yeah.
Like if you call them and they miss they don't answer, they see it on the caller ID and they call you back. Oh, hello, Mr. Fisher. I saw I missed your call. Oh, yes, I see. I could lower your bill by $10. I'll get that taken care of for you, sir. Thank you for calling. Seriously. Like, yeah, no problem.
Okay.
Thanks.
So they're a great ISP except for I
get like a 192.168.5. whatever. So I get some weird public IP address that is obviously NAT. And I don't even know how far down the NAT chain I really am. But then, of course, I have a NAT of my own network. So I have a gateway device that's connected to that NAT, which then does NAT behind it. And so, as you heard in the chat there, it is designed, Nebula, to punch through this. And it does to an extent. We can get one Raspberry Pi working for a bit. It can't talk to all the nodes, though.
Yeah, we're having a few. We haven't got it quite working. That said, we did just pick this up yesterday, and on 80% of the machines,
right, the ones that aren't behind
works.
Super crazy NAT, even mild NAT, like MiFi NATs.
Right, yeah. Tethering to my phone, no problem. Can jump into the studio.
And it's really neat to just see it work. And Wes was able to bang it out into a systemd unit file in like 30 seconds. So now it's a service that just runs on our boxes.
Yeah, no problem. Super simple.
So I have a question for Wes. I use a tool called SSH Shuttle to tunnel my DNS around from the US to Europe and stuff. Can you send with either Nebula or Tinc? Can you route DNS through those tunnels easily, or like where does the DNS actually happen?
I mean, I don't see why not. You just need an endpoint at the other side.
Yeah, so they both have provisions for it. Specifically to Nebula, there is a configuration option to declare where the DNS is, or even to act as a DNS forwarder. And so we have experimented a little bit with that, but you do kind of need a name server on either end to do it. You have to do that part.
Okay.
It's it kind of sounds hard if you don't try, but once you try it, it's really turns out if you try hard enough, you can. It's really not so bad.
No, it's not. And it's just nice. It's neat to have. We live in a world where you share things in the cloud, right? And everything is an HTTP service or HTTPS really these days. Having a flat network sort of harkens back to the good old Unix days, right? So now we could have a Samba server running here at the studio, but if it's listening on that overlay network, you can get those files from anywhere. But especially because of the security group stuff built right into Nebula, which I love, you can do that securely and not have to worry about exposing Samba to the public internet, which you just shouldn't do.
Yeah, listeners of our self-hosted program know that I have a mandate to never expose the RV to the public internet. So something like this, that's why this double net situation, I take it as a challenge because I really have a mandate to not publicly expose anything.
That's a good rule for life, Chris.
I agree. And what I love about both Nebula and Tinc, but specifically Nebula and Wireguard, they're really good about reconnecting once your connection comes back online, which is really useful for me for both laptop and the RV.
Nebula also is... It is, it's not that old. They've been using it internally for a little bit, and it's certainly new to us. But you can tell it's a modern tool. I mean, not only is it written in Go, but it's got great logging support built right in and metrics. So if you've got a Graphite server or a Prometheus server, that's built right in.
Mm-hmm. Yeah, I could see Slack building some services around this thing in the future. I could absolutely see them productizing this if they wanted to. I don't know if they will. What Ryan told us is, essentially, it's enough for them already because they have a situation where they have systems on AWS, they have systems on Azure. I'm assuming, he didn't tell me this, but they have multi-provider systems, and they want a LAN where they can have secure MySQL things happen or secure Samba things happen.
Or you can sort of abstract that away and not your individual hosts don't have to deal with that anymore. They can just receive traffic. And
I think that cross-provider thing is going to be what makes this really take off. If they keep talking about it like that, that's going to click with people. All this talk about hybrid cloud, I mean, one of the providers could be your own LAN.
Absolutely.
I have a system on Linode, I have a system on DigitalOcean, and we have the Reaper box here. I would like to connect all three of them together. Both of these allow for that.
I think it should be on one private network.
Flat network.
I haven't done extensive testing, but I did a little bit last night, just between my house and the studio, and performance is looking good. That was one of my concerns with Tinc. It's older and not necessarily optimized for performance, but this is using new quick crypto, and it did great.
Yeah, I guess it's worth mentioning. Neither one of them run in the kernel.
Just using the ton driver.
Yeah, which is perfectly fine. I think there might be probably a slightly higher performance story with Nebula than Tinc.
Yeah, I believe so.
So that's something to consider when you have a lot of nodes, right? Because Who's talked about 500 nodes, and Ryan talked about thousands of nodes. So that's something to consider too.
Yeah, and because of the the key-based and the certificate-based authentication, you don't have to do anything to add a new node. I mean, the certificate authority needs to sign the new keys for that node, but that's it. Because the Lighthouse actually takes care of communicating those details. So if I want to go talk to Chris's laptop, I don't know where that is, and I might, he might not trust that I should talk to them. All I have to do is go share my information, and because it's signed with the certificate authority, it's all good. That's it.
Yep. So if you have any questions, go to linuxunplugged.com/contact, because we're still tooling away with this. So we're having a lot of fun building networks, and I think we're going to get my NAT situation resolved. I don't know exactly how, but I think we're going to get there. We'll figure it out. Right, Wes?
Well,
right?
Maybe we'll have to ask Ryan. We'll see.
I think we might. Okay, let's do some feedback. Before we go, I said I want to do some more feedback and follow-up in this here show, and people took me up on it. linuxunplugged.com/contact. Our first one, Matthias, who says he's a happy Manjaro user in Germany. He had to mention that, didn't he?
Of course.
No, I love it. I actually love to know. He has a question about command line autocomplete. He says, short question. A while ago, you guys mentioned a cool little tool for the command line that helps me remember my complicated commands and makes suggestions while I start typing, but I forgot the name of it. I think you might be talking about Fishshell.
We do talk about Fishshell basically all the time, and it's fantastic.
Fishshell is now the thing that I install almost immediately on a new Linux box, and I go into the etc password file, and at that right there, I replace my shell with fish.
Now, another one we've, I think, mentioned before is FZF, the little command line tool, the fuzzy finder, and that also will search your command line history. So
I was thinking it could be that one too. So that's a good one. Do you want to toss a link
Absolutely.
to that in the news? All right. Liam writes, hello, Chris. I've also been experiencing random lag or skipping on my workstation with an NVIDIA GTX 1060 after I upgraded to Fedora 31. I was wondering if you ever got anywhere with the mouse lag or if it's an active bug somewhere I could contribute to.
Oh, I like what you ended up doing. This is a good sort of come clean moment.
I hadn't actually thought about. I was like, I'll do an update, doop-a-doop-a-doop. Well, okay, so, I can't stand lag. This is a particularly weak spot for me. So what I did was I burned the entire house down. I decided I wanted to switch to Plasma for a bit to see if there was an issue over there. So then I went down the rabbit hole of trying to find a great Plasma implementation. Really, I actually downloaded the Neon ISO. I was going to go just with Neon again because I had such a great experience last time.
I'm imagining you standing in front of your computer, USB drive in hand, sort of waffling, considering just about to plug it in.
That is literally the situation. I'm not kidding. And I came across and I said, Self, you don't want to always, you need to challenge your assumptions about distro, Self, because I had a real kind of realization when we put Fedora on that there server. It went so good, Wes. I was like, this is way better than I expected. I came with all these assumptions about Fedora on the server and I was schooled. So I thought, I need to give Manjaro a real go again. Because my early conceptions of Manjaro are not really, Manjaro's come so far.
It really has.
And it's really one of the great distros. And I thought, I gotta try out one of the greats. So I pulled down their Plasma edition of Manjaro, and I formatted my workstation yet again, and I put Manjaro Plasma edition on there.
I didn't think I'd ever see you remove Fedora.
I really am not trying to be a distro hopper guy. I just want to get my work done, but somehow I have fallen into this trap of working on my tools again. Maybe that's the thing I should be doing at the end of the year. Get myself positioned for 2020. Maybe that's what I'll tell myself.
Nice new workstation, everything working. Ideally, no mouse lag.
Here's the thing, Wes. Still had mouse lag.
No.
Yep. On Plasma, using X instead of Wayland, KWin, AMD graphics, still had mouse lag.
Have you considered just getting a faster mouse?
Well, I just thought about locking myself in the bathroom. Honestly, I was so upset.
Can you switch to just the console directly? Because that's
yeah. So I went down again different threads, and a common thread I kept coming across was people were noticing this issue when they were experiencing high disk I/O and GPU usage at the same time. Not gaming types of usage, but just like things that use the GPU on the Linux desktop, which Chrome uses the hell out of the disk cache and the GPU when it's rendering a page. And that is primarily when I would notice it. When I'd have a video or something playing perhaps, or something going on.
Maybe you've opened a bunch of new tabs.
And of course I've got multiple monitors. Even though I've got like an AMD 560 in there, whatever. 570 actually. I'd have the issue. I'd have lag. I'd still, even on Plasma, I'd have the damn mouse lag. So I thought, okay, well, maybe I could reduce some of this. I can't really reduce the GPU usage. That's modern browsers. But can I reduce disk I/O? And so I decided to load up profile-sync-daemon, which symlinks and syncs your browser profile directories to RAM using tempfs and RAM. Thus, it reduces the hard drive calls. It speeds up your browser. I want to make it clear here. I'm doing this on a really nice NVMe, okay? I've got...
It's not some 5400 RPM.
No, it's no slouch. I legitimately noticed an improvement when I did this.
I mean, have you tried RAM? It's the best.
It is the best. Everything's faster. What's great about profile-sync-daemon, besides the fact that it could cause you to lose your entire profile, is that it supports like all of the browsers, even Vivaldi, and I'm not sure about Brave, but like all the different browsers. And it automatically detects them if you like, and it handles and manages the syncing to RAM and back. So you want to properly close and open your browser at the beginning and the end of your day to give it a chance to sync. You'll notice if you watch the cache usage from your the kernel file system cache, you'll notice if you watch that indicator closely, you can see it blast the cache as profile-sync-daemon does its sync. It saturates it complete on my system. With, I think this box, it's either 32 or 64 gigs of RAM. I mean, it just uses a ton of cache for like 15 seconds. It's really fast because it's going from RAM to an NVMe.
Right.
But if you were to lock up and hit reboot, it would never have had a chance to write that profile back to disk, and so any changes would be lost. Now, the nice thing is that's pretty much mitigated these days by browser sync for the most part.
Right.
So it's constantly syncing to the Vivaldi cloud service, and yeah, I'm on Vivaldi too. A part of this I switched over to Vivaldi. That's a whole nother story. But so, thank you for asking about the mouse leg.
Hey, it works out well, too, because, of course, profile-sync-daemon is in the AUR.
Of course it is. Yeah, but it's pretty much available for anything. I think my suspicion is that something is no longer great on my box, or perhaps my original suspicion is that around kernel 5.2 time period, somewhere when I transitioned from the 4 series kernel from an older distribution to the 5 series kernels on this box, that's when these problems manifested. I do suspect if I were willing to not have the latest goodies...
So you're saying you're going to switch to Neon?
Yeah, because you're like, what, on 4.16 or something?
Well, let's find out.
Because I never had leg on Neon. Same hardware.
4.15, baby.
Yeah, and when I used the GNOME implementation of Ubuntu, that's on 18.04, I didn't have mouse leg. It wasn't until I went to 5 series kernels that I started getting mouse leg, and I wonder if this is never going to be fixed. It's kind of getting, 3-year-old box now, something like that, getting there, 2.5, something. People are not going to be releasing new drivers or it's just, I think I'm doomed. So my solution is to just reduce the disk I/O while using GPU for web rendering stuff. It doesn't seem to affect games. Doesn't seem to affect that stuff.
How well does this actually work? I mean, do you still get occasional mouse lag, or is it pretty much gone?
Very, very well. Nearly gone.
Excellent.
Maybe a glitch or two a day now instead of every few minutes. It's a huge difference.
So you can use your nice computer now.
Yeah. So give that a go. See if that works for you. I don't know if it will. Okay, now we got to get out of here, but we'll do one more. So, because I promised, it's towards the end of the year we start doing this. And we'll do another batch if you'd like, linuxunplugged.com/contact. But I think this is a good one to end on. Cameron writes in, regarding some requests for feedback, I'd love to have a forum for the podcast, or better yet, for Jupiter Broadcasting as a whole, so the listeners and maybe you guys can all communicate and share info, news, etc. So that's something we've actually been talking about internally.
Indeed.
We have been around for so long now that we have had about 3 different iterations of, if you count before Jupiter Broadcasting was formed, probably 5 different iterations of community forums. Some of them were so large that's actually how we ended up starting to work with Alan on Scale Engine, is we had to move on to infrastructure that could handle the amount of traffic we were getting. So we definitely have had some in the past, but they generally over time kind of decline.
Mm-hmm.
And they become a pretty large source of work. And I want our interactions with the community to be excited, like we're excited to do it, not a chore.
Absolutely.
So our current outlets are not they're not like something on the web. And that's what's so great about forum software, because we do have the IRC, irc.geekshed.net, #Jupiter Broadcasting, #Octothorpe. So of course we have that. That's a persistent chat going all the time. But we also have the Telegram group, jupiterbroadcasting.com/Telegram. There's over 1,000 people in there chatting, usually about 100 online at any given time. And then last but not least, we actually have a Discord too. We don't do much with it, but there is a Jupiter Broadcasting Discord, and I'll put a link in the show notes. I mention all of those because we do have some outlets of persistent chat where you can come and talk about the shows. But the nice thing about forums is you've got topics. You can, episode 329 of Linux Unplugged, where they talked about flat networks.
Right. It is a different thing. It's its own beast.
So I could be convinced of it again.
Probably need some feedback about it, though.
And what would be the advantage of that, say, over the Jupiter Broadcasting subreddit, which we've never really mentioned, but we have a Jupiter Broadcasting subreddit, which also kind of acts in that forum capacity. But not everybody wants a Reddit account. But not everybody wants to go make a forum account. So feedback, linuxunplugged.com/contact. Probably won't read them all on air, but we will read them off air and help it inform our decision. So there you have it. We did some feedback. Really quick before we run, also just a few picks to mention because I love these. Check out WeSlack. It's a WeChat plugin for Slack, and its developer was Ryan, our guest today.
Yeah, it has its own community now. It's its own thing, but he started it all.
Yeah, he no longer is even involved, but it's still a thing. So if you want to use Slack still in an IRC client, It's possible using WeSlack. And then I came across, I don't even know how I'm going to say this one, Grinds. What do you say, Wes? Give it a shot.
Yeah. Why do you do this to me?
Girins?
Yeah.
This is a fairly slick GTK desktop front end to Plex.
We finally have one.
Why would you want this, you say? I'll tell you why. Because browsers are monsters. They take everything, your disk, your CPU, your RAM. They make your damn mouse leg. They are the worst. They're huge. One tab takes up way more CPU and memory than it should. During some of our benchmarks, we have seen when a system gets loaded, we have seen how a browser tab can bring a system down to its knees when it's under load. It's crazy. This does none of that. It's a native, clean client. When it's sitting there and you're not playing anything, it's not using any resources. It just sits there quietly, doesn't peg your CPU constantly. And when you do want to play, it takes only the amount of resources it takes to just decode the video, which is probably pretty damn fast on your system. It's glorious. And it's a GTK application, so it looks great on your GNOME shell.
What am I going to do with all this extra CPU time?
I don't know. Run Slack probably. But I was so elated when I found that because I like to have I have series on Plex that are like my barely kind of just background stuff that I play while working.
Oh, yeah.
So now throwing it up on a screen and not eating a bunch of resources while I'm working is fantastic. Trying to reduce resource usage, even though I have 12 cores. It's ridiculous. One more mention for that Black Friday sale because we're just super excited about it. It's a great opportunity, and we have the best courseware on Linux, DevOps, of course, AWS and Azure and Google Cloud.
Oh, boy.
And remember those hands-on labs. The value is incredible. Learn.linuxacademy.com/Jupiter. And Mr. Payne, you're over there on the TechSnaps, techsnaps.systems.
TechSnap.systems.
There's no S on the TechSnap, but I like saying it.
Don't confuse everyone.
I like saying it. I like it. So, yeah, I've been really enjoying it. Give my rounds of compliments to Mr. Salter because I think he's really... Both of you really hit your groove for a while now on that show. So it's like when it's like good for a while, you know? I love that.
Totally agree. Awesome show.
And of course, Alex and I on Self-Hosted next week. Brand new episode of Self-Hosted.
Oh, I'm excited.
Tomorrow, live stream, live Self-Hosted hack tomorrow, Wednesday, jblive.tv, 10:30 a.m. Jupiter broadcasting time. Alex is going to do a little live hacking on the stream.
Oh.
Just a little Self-Hosted Bobo for Self-Hosto.
ESP8266 hacking and LEDs and all that kind of stuff.
Yeah. Sounds like just what we need to start off the holidays.
I know. I love it. Of course, all of that can be found at jupiterbroadcasting.com/calendar. We're at linuxunplugged.com. And we'll see you right back here next Tuesday. Before we get out of here, jbtitles.com, I have a question for the virtual lug. Does anybody own a USB stick that they could still find that is less than 16 gigabytes?
Megabytes.
Megabytes?
Megabytes.
We have one for, no, megabytes?
Hey, I mean, Joe does not play.
Yeah, Joe has a 16 megabyte SD card.
No, not megabyte.
Oh, wow, I can't beat that.
Yeah, I have a 256 megabyte SD card.
256 also here.
I thought I'd be Mr. Briggsy here with my 4 gigabyte.
You know, he just keeps his favorite GIF, just one on there. Oh, sorry, GIF, is that what you prefer?
Hey, do you remember those early digital cameras that actually took an entire floppy disk? They took a 1.4 megabyte floppy disk, and then they saved the horrible JPEGs to the floppy?
Yep, I think it was a Canon camera, and I think you could get 12 photos on one floppy, I believe.
You would have killed for 16 megabytes back then.